Hello and welcome to this Kibana tutorial. My name is Bo Anderson and I'll be taking you through the very basics of Kibana. We won't dive deep into things in this video, so this is just a tutorial for getting started with Kibana and getting an overview of what it's all about. If you want to dive deeper into Kibana, be sure to check out my Kibana course, which I have linked in the description. Alright, let's get started. So what is Kibana? Kibana is a user interface that's used to visualize and analyze Elasticsearch data. The interface is accessible through a browser, and Kibana ships with a built-in web server. The Kibana server communicates with an Elasticsearch cluster to retrieve its data. Kibana also stores all of its data within Elasticsearch indices. This is convenient because it means that we don't have to manage a database with this data and handle things such as backups. If we lose the server on which Kibana is running, we still have all of our data within our Elasticsearch cluster, and we can continue where we left off on a new instance. Alright, so what can we actually do with Kibana? We can build visualizations, such as pie charts, bar charts, maps, heat maps, gauges, tag clouds, etc. Basically any visualization type you would expect. These visualizations generally make use of Elasticsearch aggregations under the hood. With these visualizations, we can build dashboards to create an overview of our data. An example could be to show the hardware utilization of servers, or to display application metrics. Dashboards can be created for people with different roles, which you can see an example of on your screen. They can be interacted with to dynamically slice and dice data, so dashboards are not necessarily static. We can create users with each of their credentials and have a user for each employee in a company, for instance. We can then control what they have access to with roles and spaces. For instance, we could have a space for the sales department and one for the system administration department, both showing different things. That's useful because we probably don't want sales managers being able to see our server monitoring, while system administrators probably don't need access to sales data. While showing data within Kibana is great, sometimes we might want to show things in a different context. Kibana enables us to share data in a number of ways, whether it's visualizations, dashboards, or even raw data. For instance, we can download a dashboard as PDF, which can then be sent to a colleague, boss, customer, or anyone really. We can also download PNG images of visualizations and use them within presentations, for instance. Or we can even share links to dashboards or even embed them within other web pages. Needless to say, regardless of how we visualize our data, those visualizations are not stuck within Kibana. We can also set up alerting within Kibana and be notified when certain criteria is fulfilled. An example could be that we want to be alerted if there is a sudden increase in internal server errors on our website, or if the CPU usage of a server exceeds 85%. Each alert is based on data within an Elasticsearch index. We define the alert condition, how often the alert should be checked, and how often we should be notified if the condition evaluates to true. We can then be notified in a number of ways, such as email, Slack, or webhooks. That was a quick overview of Kibana. Surely there's much more to Kibana than that, but those were some of the highlights. We won't cover all of the features I mentioned in this video though, but now you know what Kibana is capable of. Now that you have been introduced to Kibana, let's get started actually doing something with it. The first step in doing so is to set up Kibana. Since Kibana requires an Elasticsearch cluster, you will need to set that up as well. There are essentially two approaches that you can choose: to set up Elasticsearch and Kibana on your own machine, or to run everything in the cloud. By cloud, I'm referring to Elastic Cloud, which is the official cloud solution from the company behind the Elastic Stack. I actually recommend that you go with the cloud approach for a couple of reasons. Firstly, it's easier. Everything is set up for you, just by clicking a few buttons, meaning that you don't have to deal with Java versions, environment variables, and similar issues that may occur when setting things up on your local machine. Secondly, there is a difference when it comes to licenses. Most Elasticsearch and Kibana features are openly available, but some do require a license. That's not the case for any of the features I'll show you in this video though. By using Elastic Cloud, we automatically get a license where all features are available, so you can play around with Kibana and use any feature. Third, if we set things up locally, certain features require us to do some additional configuration that's automatically done for us with Elastic Cloud. An example is using security features, such as users and roles. While the configuration is fairly easy, it does require us to spend a bit of time within configuration files as well as the terminal. There is a free 14-day trial available for Elastic Cloud that you can use if you want to follow along. You don't have to enter any credit card information, and the trial automatically expires, so you won't be charged anything. I've attached a link to the trial in the description. To save some time, I won't actually show you how to create an Elastic Cloud deployment, since it's just a matter of clicking a few buttons. I do have a video on my channel showing how to do it though. If you want to install Elasticsearch and Kibana on your own machine, that's also easy. I've attached a download link to Kibana in the description as well. That page includes the instructions for how to set it up. Kibana is not much fun without any data, so let's add some. I have prepared a file containing some randomly generated Nginx access logs. The file is formatted to be compatible with Elasticsearch's bulk API, which you may be familiar with. You can find a download link in the description. To import the data, we'll be using the bulk API through the curl HTTP client. Curl should already be installed on whichever operating system you're using. We haven't created any Elasticsearch indices yet, so naturally we don't have any field mappings either. If we wanted to change how data is stored within Elasticsearch, we would create an index template before importing the test data. This would give us control of data types among others. For the purpose of this tutorial though, we'll just import the data and let Elasticsearch create default mappings for us, which is referred to as dynamic mapping. Anyway, let's import the data. I've extracted the zip file in advance, so let's open up a terminal window and write a curl command. Naturally, the command begins with curl. Following that, we need to specify the content type header, which we can do with the -h argument. This header should specify the ND-JSON content type, so that Elasticsearch knows which type of data it's receiving. Let's type that out. Then we need to specify the HTTP verb. If we leave it out, it defaults to get, but we need it to be post. We use the -x argument to specify the verb. Since I'm using an Elastic Cloud deployment, I need to authenticate my request by specifying my username and password. That's done with the -u argument. To be clear, the credentials are for the deployment, not your Elastic Cloud account. If you set things up on your own machine, you can skip this step. Next, we should enter the URL to our Elasticsearch cluster and the bulk API in particular. You can grab the endpoint from the deployment page on Elastic Cloud. For local clusters, the endpoint will be localhost on port 9200 by default. Notice how I didn't specify any index name within the endpoint. That's because the bulk file actually contains the name of the index that documents should be indexed into, and so we don't need to specify this within the endpoint. Finally, we need to actually send some data along with the post request. We do that with the data-binary argument. Notice that this argument must be prepended with 2 hyphens instead of just 1. Then we add the file name within double quotes, prepended with an @ symbol. This symbol tells curl that the value is a file name and not a path. Let's type that out. We send the file content along as binary data, because we want to preserve the new line characters. Other curl arguments process the data, causing new lines to be removed. That's it, let's run the command. After a short moment, Elasticsearch responds with information about the operations contained within the bulk file. We can inspect the results if we want to, but the data should have been ingested correctly. Let's head over to Kibana now that we have some data to work with. You can find the link to launch Kibana on your Elastic Cloud deployment page. For local setups, navigate to localhost on port 5601. Before we can get started exploring our data, we need to create an index pattern. So what is that? An index pattern defines which Elasticsearch indices Kibana should retrieve its data from. Suppose that we have an index named orders containing order data. Now we want to create a number of Kibana visualizations for this index. This could be a line or a bar chart showing the number of orders over time, and a pie chart showing the most popular products. For each of the visualizations, we need to tell Kibana which Elasticsearch indices it should retrieve the data from. Instead of entering the name of an index, we create an index pattern. That's because storing data in multiple indices is a common approach in Elasticsearch, and so we want a more flexible approach. An index pattern matches one or more Elasticsearch indices with a pattern that optionally includes wildcards. Since we just have a single index in this example, we can just enter the name of the index as the pattern, i.e. orders. We then choose this index pattern when creating the visualizations, causing data to be retrieved from any indices that match the index pattern. In this case, that would just be the orders index. Although we only have a single index containing orders, we might as well add a wildcard at the end, just in case we need to split the orders data into multiple indices in the future. If that happens, we won't need to modify the index pattern as everything will work the same automatically. Let's see an example of just that for a different dataset. Suppose that we have 3 indices storing HTTP access logs, 1 index per month. That's because we're running a busy website, and so storing all of the access logs within a single index does not scale well enough. This approach is referred to as time series data, which is a common use case for the Elastic Stack. Using time-based indices means that we can't just specify an index name explicitly, because there's more than one and they have different names. I'm sure you guessed that the solution is to use an index pattern with a wildcard. The index names should then follow some kind of naming scheme that matches this pattern. That can be as simple as increasing a number by 1, or, as in this case, using a date. With the index pattern you see on your screen now, we can match our 3 indices and any that might be added later. When we create our visualizations with this index pattern, Kibana will construct Elasticsearch queries that search through all indices matching the pattern. Using wildcards in index patterns is therefore a way of dealing with time series data that's divided into multiple indices. This enables us to work with the data as if it came from a single index, even though several indices are queried within Elasticsearch. Pretty cool, right? For clarity, I should mention that index patterns are not specific to visualizations. They are used throughout Kibana when we need to access underlying Elasticsearch data. Okay, so now that you know what an index pattern is, let's create one. That's actually required before we can interact with our data within Kibana. Let's expand the menu and click Stack Management at the bottom. Then click Index Patterns in the second menu that appears within the Kibana group. And then click the button. First, we need to define the pattern to match our indices, being one of the patterns that you saw in the example a moment ago. Let me just type that out. In case you didn't notice, Kibana automatically adds a wildcard once you start typing, because that's often how you will use index patterns, instead of specifying the name of a single index. Kibana checks if the pattern matches any index names. It matches the index that was created when we imported our test data, so everything looks good. Let's continue to the next step. The last thing we need to do is to specify the date field that Kibana should use when filtering documents based on time. In our case, we have a field named @timestamp, which is the timestamp of when a given request was received. That's the one we'll use, so let's go ahead and select it. There's nothing else we need to do, so let's go ahead and create the index pattern. Once the index pattern has been created, Kibana inspects the mapping of the matching indices. Within the table, we can see the list of fields along with their data types and how we can use them. This is basically the field mappings presented within a user interface, along with how the fields can be used. That's all there is to index patterns really. We're now all set up and ready to get started with Kibana. Let's start out simple by looking at a development tool named Console. This is an incredibly useful tool, and there is a fair chance that you're already familiar with it. If that's the case, feel free to skip ahead, as I probably won't cover anything you don't already know. The Console tool lets us send queries to our Elasticsearch cluster using a convenient syntax that's much easier to use than sending requests with curl, for instance. It helps us in a number of ways, including JSON formatting, auto-completion, etc. Let's see what it looks like. The tool is located within the DevTools app, so let's open that up. To the left is an editor where we write queries, while query results appear to the right. As you can see, an example query has already been added to the editor. I'll get back to that one in a moment. First, let's type out our own query though. Let's write one of the simplest possible queries that returns the health of our Elasticsearch cluster. First, we enter the HTTP verb for the request, which is GET for the API that we are going to use. Following the HTTP verb is the request path. We'll use the cluster health API, so let me just type out the request path for this API. Notice how Kibana helped me type that out with auto-completion, which is quite convenient. Also notice how the leading / within the request path is optional. If we don't add it, Kibana will do so for us automatically. I just like to include it, but that's just a matter of preference. To run the query, simply click the small triangle to the right. The results are displayed as a pretty formatted JSON object to the right. Don't worry if you don't get the same values within the results, because that depends on your Elasticsearch deployments. Most Elasticsearch APIs require a request body containing parameters. An example of that is the query that was added for us in advance. The body of requests is simply added as a JSON object below the header. By header, I'm referring to the HTTP verb and request path. This example query contains the match_all query within some simple query DSL. Let's run this query as well. To the right, we can see the search results being exactly the same as we would get if we used any HTTP client, for instance. Those were the basics of the Console tool. It might not seem like a big deal, but this tool is actually super convenient for writing queries, compared to writing curl requests on the command line, for instance. I use the Console tool myself for writing ad hoc queries. It's also useful if you're a developer, because you can write and test your queries here. When you're done, it should be fairly simple to translate them to one of the Elasticsearch client libraries, or a plain HTTP request for that matter. We won't be using the tool in this video, but it's good to know that it exists and how to use it. Alright, let's cover one of Kibana's apps, specifically the Discover app. This app is super useful for exploring data. You can quickly slice and dice data to find what you're looking for. Perhaps we need to investigate an increase in the 404 HTTP status code. We can easily find those documents by applying a filter and then interactively narrow down our search from there. Before we get to that, we need to show some data, since our current search doesn't match anything. That's because a default time filter has been applied, which matches documents created within the past 15 minutes. Our test data is for January 2021, so we need to modify the time filter. There are quite a few presets here that we can use, but in our case we need to specify absolute days. To do that, we need to click on the Show Dates link. First, let's choose January 1st, 2021 as the start date. And then choose January 31st, 2021 as the end date. Now that's done, let's click the button to update the search. Now we see some data because the date filter now matches the timestamps within our test data. Let's quickly take a closer look at what we can do with the Discover app. Since this is an introduction to Kibana, I'm not going to cover things in detail. At the top is a search bar, which we can use to filter documents using KQL. KQL is short for Kibana Query Language. It's a simple but powerful query language, which is translated into Elasticsearch queries by Kibana. I have another video covering KQL, so I'm not going to go into detail here, but let's write a super simple query that matches all requests from Germany. Fortunately, it's pretty easy with Kibana's interface without knowing KQL. And just like that, the interface only displays requests that originated from Germany. We could also have accomplished this with a filter, which is just another way of filtering documents. Let's add a filter to match requests made with Windows as the underlying operating system. Conveniently, Kibana lists the top values for the field, so we can simply choose one of them. Now we're seeing the requests from Germany that came from the Windows operating system. Pretty easy, right? Below the filter, we can choose which index pattern we want to use. In this case, we only have one. Below that, we have a list of the available fields for the chosen index pattern. If we click one of them, we'll see a couple of useful statistics, including the top 5 values. Notice how the cities are German in this case. That's because the top values take any KQL query and filters into account. We also gain access to a few shortcuts here, such as filtering based on these top values. Anyway, let's continue. At the top, we have a bar visualization, showing the number of requests over time. In this particular visualization, the bars represent 12-hour increments. That's done automatically based on our date filter, but we can change it if we want to. If we were to show data for 2 months instead, for instance, each bar would represent a full day. Something that's super convenient is that we can click and drag on the bar visualization to adjust the date filter. Just like that, the date filter has been updated. That's just an interactive shortcut for drilling down into the data. Below the bar visualization, we can see a list of the Elasticsearch documents that matched our criteria. We can click the small icon to the left to expand each document. This gives us a more structured table view of the document. Hovering a row in the table, we get access to shortcuts, such as adding filters that include or exclude the value and more. We can also see the raw JSON object that was returned by Elasticsearch. That's the basics of the Discover app, which is useful for exploring and digging into your data. There is a bit more to it than this. I encourage you to open up the app for yourself and play around with it to see what else it can do. Or you can of course check out my Kibana course, which covers it in a bit more detail. Before continuing, I will just quickly reset the date filter to what it was before. Alright, let's continue to the next topic, visualizations. Kibana ships with a number of visualization types that we can use to create good-looking visualizations based on our data. A couple of examples are pie charts, line charts, heat maps, tables, etc. Naturally, I won't cover all of the visualization types in this video, so I will just give you 2 examples. Elasticsearch aggregations are the foundation for Kibana visualizations, so it's important to understand at least the basics of those. I'm not going to cover that here, but I do have a video on the subject that you can check out if you feel you need an introduction. Alright, let's head to the Visualize library, which is the home of the visualizations within Kibana. If we already had some visualizations, we could manage them here. Let's create a new one since that's not the case. We are then presented with a few choices. The ones you will typically use are the lens and aggregation based ones. Kibana Lens is a tool for dynamically building visualizations. Kibana does a lot of work for us automatically based on the options that we choose. Aggregation based visualizations require more manual configuration. All Kibana visualizations use Elasticsearch aggregations under the hood, so don't be confused by this naming. I'm not going to cover Kibana Lens in this video, since that would be pretty time consuming, but feel free to explore it on your own. Instead, I'm going to go with the aggregation based visualizations. Here we can choose between a number of visualization types, some of which I mentioned a moment ago. Let's go with a pie chart. Each visualization is tied to an index pattern, determining which Elasticsearch data is used. We only have one, so let's choose that one. This is the space where we can configure the pie chart. Currently it doesn't look that interesting, because it just shows a circle without any so-called slices. To the right, we can see that we're using a count metric, being the document count. This means that the pie chart currently represents the number of documents matching our date filter. I'll get back to metrics in a moment, but first let's talk about buckets. A bucket in this context is the same as it is within Elasticsearch aggregations, meaning that a bucket represents a collection of documents. Let's add one. For the purpose of this video, I'll go with the split slices option. Then we need to choose an aggregation. Let's go with the terms aggregation, which creates a bucket for each term up to a configured limit. Let's visualize the top 5 countries, so I will choose a field containing the country name. Let's leave the rest of the options at their default values and click to view the pie chart. And just like that, we have a pie chart showing the top 5 countries. We can hover the slices to show the values that they represent. This is a useful visualization already, but let's make it slightly more advanced by turning our attention back to the metrics. Instead of showing the document count for each slice, i.e. bucket, we can use a metric aggregation. Let's calculate the sum of a field's values for each bucket. As for the field, let's go with the number of bytes. The pie chart now shows the total number of bytes for each country. That's probably not too useful, but that's just the data we had to work with. For an orders dataset, we could sum the order amounts for each country, for instance. Note that just as with the Discover app, we can also add filters and a KQL query for visualizations to narrow down the matching documents. The visualization uses the date filter that we have chosen, but it's important to understand that these dates are not stored together with the visualization. This means that if we were to place the visualization on a dashboard, for instance, its data would not be locked to the date filter that you see now. Instead, the visualization can work with any date filter and would use that of the dashboard instead. You will see that a bit later. Anyway, each type of visualization has a number of options to configure its appearance. Let's uncheck the donut setting, for instance. That looks much better, at least in my opinion. I won't cover the rest of the options, so feel free to play around with them yourself. Let's save the visualization so we can place it on a dashboard later. Let's give it a meaningful title. To the right, we can choose to add the visualization to an existing dashboard or to create a new one on the fly. That's just a convenient shortcut that improves your workflow. Actually, you will often create visualizations from within the dashboard app, but you will see that later. Let's just save the visualization without adding it to any dashboard. That's it for pie charts. Let's create another visualization, being an area chart this time. Navigating to the Visualize library this time, we see the visualization that we just created. The interface for configuring an area chart looks fairly similar to what you just saw. Unlike a pie chart, an area chart is almost always used to display values over a period of time. That period of time has already been chosen with the date filter, but we still need to configure the intervals. By interval, I'm referring to how much time is between each of the points on the x-axis. Let's do that by adding a bucket, specifically an x-axis bucket. As for the aggregation, let's choose date histogram. Our add timestamp field has automatically been selected for us, so that's pretty convenient. As for the interval, we have a couple of options. I'm just going to leave it at auto. This means that a suitable interval is chosen for us automatically based on the date filter. Let's collapse the bucket since we're done configuring it. Notice how the bucket now states an interval of 12 hours. If we were to display data for 2 months, for instance, we would see an interval of 1 day instead. And likewise if we chose a shorter date range. Anyway, let's click to update the visualization. Now we can see the number of requests over time with 12-hour intervals. Just like with pie charts, we could choose a different metric if we wanted to. Let's try something fun and add another bucket. Since we have already configured the x-axis, we cannot do it again. Instead, we can choose split series, which lets us display multiple values. As for the aggregation, I'll go with terms. Let's then go with the country name field again, just as with the pie chart. And then update the visualization. Okay, so that looks pretty strange. What I want to show is how many requests were made from the top 5 countries over time. To get that, we need to rearrange the two buckets, i.e. to switch them around. Let's see what it looks like. That's much better. This constructs an Elasticsearch aggregation yielding the top 5 countries. For each of those countries, a bucket is created for each date interval, being 12 hours. This is what is displayed along the x-axis. Pretty cool, right? The area visualization also has a number of settings. I'm personally not a fan of how the visualization looks right now, but I suppose I can live with it for the purpose of this tutorial. Let's save the visualization before moving on. Now that we have a couple of visualizations, let's move on to talking about dashboards. A dashboard is a collection of so-called panels that show data. A panel typically contains a visualization, but can include data from other Kibana apps as well. In our case, we can place our pie chart and area chart within each of their panels. Although not strictly required, the data that's placed on a dashboard is typically related somehow to provide an overview of data. For instance, we could have a dashboard for showing the health of web servers, another for showing order data, and yet another for showing an API's performance metrics. Whatever the case, the purpose is to provide an overview of data. Let's create a simple dashboard within the Dashboard app. As with the Visualize library, any existing dashboard would be listed and managed here. Alright, this is where we configure our dashboard. The top looks familiar with the date filter, KQL and filters. To get started, we need to add a panel to the dashboard. If we click the Create Panel button, we can create a new visualization on the fly through an integrated workflow. This process is much the same as we did a moment ago. Since we already have two visualizations, let's click the Add from Library button and choose one of our visualizations. As you can see in the background, the visualization has been added to the dashboard within a panel, so let's navigate back to it. To make things look better, let's make the panel take up the full width of the dashboard by dragging the bottom right corner of it. That's better. Let's also hide the legend, because why not? Each panel has a number of options, so let's take a look at some of them. By default, a panel uses the title of the visualization that it contains, but we can change that if we want to. We can also create so-called drill downs. A drill down is a way to interact with a panel, typically being to navigate to another dashboard. For instance, clicking a country on our pie chart, we could navigate to a dashboard that shows data for just that country. Drill downs are outside the scope of this tutorial though. By default, a panel uses the date filter of the dashboard, but we can change that if we want to, such that it uses a custom time range. We can also inspect both the request and response associated with a panel, which is useful for debugging purposes. Perhaps we're seeing unexpected data, in which case we can investigate further with this option. The rest of the options are fairly self-explanatory, so I will leave it at that. Let's add our pie chart to the dashboard as well. Since we don't have other visualizations to add, let's just stretch out the pie chart as well. Alright, that's our super simple dashboard. Let's save it. I'll just name it Countries. Here we also have the option of storing the date filter together with the dashboard. If we don't do this, the dashboard will be dynamic and use whatever date filter is configured. If we enable this option, the dashboard will be locked to the date filter that we currently have. That might be useful if you're building a dashboard for the current or past year, for instance. Of course, you can change the time at a later date. Anyway, that's not useful to us right now. Our dashboard has now been saved. Perhaps you noticed that it now looks slightly different. That's because we're now in view mode, whereas we were in edit mode before. As a result, some things have been hidden, such as the dashed panel borders and resize controls. As a last thing, I quickly want to show you that dashboards are actually interactive. Look at what happens if I click one of the slices on the pie chart, for instance. Notice how the dashboard now only shows data for that country, because a filter was automatically added for us. Likewise, I can select a time period within the area chart to update the date filter, just like we did within the Discover app. And just like that, the date filter along with all of the dashboard's data has been updated. How we can interact with each panel depends on which visualization type it contains. Alright, we are almost at the end of this Kibana tutorial. Before wrapping things up, let's take a short moment to talk about what we didn't cover. That's of course a lot of things, so I'll only mention key features here. First up, we have the Canvas app, which is basically dashboards on steroids. Canvas gives you much more control over the visualization and presentation of your data than dashboards do. Dashboards are focused on presenting a limited number of visualizations with simple styling options. Canvas, on the other hand, provides much more control over the visual appearance of your data, including the options to include custom CSS, images, etc. Think of it as building a PowerPoint presentation based on live Elasticsearch data. In a nutshell, Canvas is a highly customizable way of presenting your data within Kibana. I briefly mentioned what Kibana Lens is about, but let me recap on that. It's an easy to use and intuitive interface that simplifies the configuration of visualizing data. It does that through a drag and drop interface, which abstracts many of the technical details away from you. Oftentimes, you will be able to build visualizations without ever worrying about what the underlying aggregations look like, for instance. Lens will automatically make intelligent suggestions and enable you to switch effortlessly between visualization types. The machine learning app is where we can create machine learning jobs, such as for anomaly detection and analytics. For instance, we might want to monitor the number of requests made to a website and detect if anything unusual happens. This could be a drop in requests, signaling the possibility of a technical issue. Or perhaps an unusual increase in visits, which could be a sign that we need to allocate additional hardware resources. We could also monitor various HTTP status codes, for instance. Another example of what we can do is to forecast future values based on historical data. For instance, it might be worth forecasting future traffic to a website to avoid running out of server capacity. Kibana is often used for observability. In case you're not familiar with that terminology, it's essentially about providing insight and visibility into how your applications and infrastructure performs. This includes logs, such as access and error logs for web servers. In terms of metrics, a couple of examples are hardware and operating system metrics, such as CPU and memory usage. Using APM, which is short for Application Performance Management, we can also capture traces and performance metrics from within our applications to identify things such as slow requests and gain insight into what causes them. We can see how much time is spent on database queries, sending requests to third-party services, etc. Kibana is also used to monitor the Elastic Stack, such as Elasticsearch and Logstash. You can find everything from hardware utilization to search and ingestion latencies, index statistics, etc. Pretty much everything you need to monitor the health of your deployment of the Elastic Stack. Apart from monitoring the Elastic Stack, we can also manage it within Kibana. We can do things such as manage Elasticsearch ingest node pipelines, indices, index lifecycle policies, snapshots, Logstash pipelines, and much more. We also didn't cover security features, such as adding users, including how to define their privileges with roles and spaces. Last but not least, we can set up alerts, which I mentioned at the beginning of the video. These will automatically trigger when certain criteria is fulfilled. There's even more we can do within Kibana than that, but I don't want to ramble on for hours, so I will leave it at that. So that marks the end of this tutorial. If you want to learn more about Kibana, then be sure to check out my full Kibana course, which covers more features than the ones I showed you here. Thank you so much for watching. This wouldn't be a proper YouTube video without asking you to like and subscribe, so here it comes. Please like and subscribe. I hope I'll see you in a future video. Take care.